I will call this the Bayesian Mantra. Can you say, what is the Bayesian Mantra in words from last time?
Posterior.
Posterior is proportional to likelihood multiplied by prior. Yes. So what is the likelihood function? The likelihood function is theta given on the data that we have. So x1, x2, dot, 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 xn. What do we do with the likelihood? We try to estimate the value of theta. In order to do that, we want to know how likely each of those observations are, individual ones. How can we compute that? Any thoughts? Over here. So for a given value of theta, I want to know what are the chances, not actually a probability, what is the likelihood that I would get x1 and x2 and x3 and xn? You multiply, but what are you multiplying?
Quick question.
Yeah.
You said given theta, what's the chances you find x's? Isn't that backwards how that's written? Isn't that given
No,
x's?
I'm talking about over here, and not on that side. So I'm coming up with a theta value equals x1, x2, all the way up to xn. Over here, if I picked a theta value,
Oh, we're doing that switch.
right,
Okay.
so what would I use to come up with this formula for likelihood?
The product of xi given p theta.
Okay, xi given theta,
Times
what
PR.
function though?
PR of xi.
PR, but if it is continuous,
F.
f, the density function, right? So f of xi given theta. That's great, you can of course use PR, but this is more generalized. When we have density and we multiply all the values are going to be very, very small. So typically, instead of using the likelihood function,
Those letters.
we use the log likelihood instead. So if we use the log likelihood, what would happen?
If the product becomes a summation.
The product becomes a summation, and ln of f of xi given theta. Yes, so, and we are trying to maximize the log likelihood anyway. So pick a theta and evaluate this, get a value of log likelihood. Pick another theta, evaluate this, get another log likelihood for that theta, and see which theta gave us the maximum value. And that will be the parameter from which this came from. Good? Now, the posterior is for the parameter theta. Yes, because if you go back to the simulation, we computed the posterior for beta naught and beta 1. So the posterior is theta given x1, x2, all the way up to xn. Yes? And that would equal to, if we look at it as probabilities, probability of theta given x1, x2, dot, 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 all the way up to xn. Call that D, sticking to notation that we already have. So stands for data. How can we rewrite this? So P by P, I mean a posterior distribution. Over here, I just want to relate it to Bayesian rule, Bayes rule. So how can I rewrite probability of theta given D? Probability of theta given D is probability of theta and D divided by the probability of D. Yes? Multiplication. I can rewrite probability of theta and B as probability of D given theta multiplied by probability of theta divided by probability of D. Good. So I'm not directly equating this to that. This is actually a function that I'm just using Bayes rule to write posterior distribution in terms of its likelihood and prior. So if I go back to that funny notation of converting this to a function, I can call that as P of theta, correct? So the posterior of theta given the data is equal to converting the individual probability as a function probability of data given theta multiplied by the probability of theta divided by, or probability, the function of theta divided by a function of the data, which is D. Now, if you look closely, this function, data given theta, what does that remind you of? Replace D as x1, x2, all the way up to xn. If
least squares,
least squares,
it's a fitted function.
so go back to the notation. So what I did is I started with this function. I wanted to connect it to Bayes rule. I got this finally. If I replace that P as x1, x2, dot, 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 xn, given theta, what could this function be related to? Go back to what we started from earlier. What does that look like?
Sort of looks like likelihood.
Sort of looks like likelihood. Do you agree? So if I took an individual observation, then all of this notation would be perfectly fine, correct? But I'm taking x1, x2, x3 all the way up to xn. So this part simply would be the likelihood. That part is the prior. The denominator is what we call the marginal likelihood. But the marginal likelihood doesn't always play a significant role in determining the posterior. It is useful, but sometimes you can omit it which is why we write it as probability of theta given d is proportional to probability of d given theta times, not probability, let me correct myself. The posterior distribution of theta given d is proportional to the likelihood multiplied by prior distribution of theta. Good. That's the posterior prior likelihood. To distinguish, maybe we'll use a different notation, slightly different notation. So we'll call this P underscore post, P underscore LL, P underscore prior.